Right, this is the first section of Unit 4. So this is it. This is the last unit we're covering. All right, permutations and combinations. All right, permutations and combinations, these are a way of figuring out how many different ways something can occur. All right. You also have our first thing here, fundamental counting principle. This also gives you the different ways that items can occur. So if you have two different things, two different items, the way that they can occur together is you take the number of ways the one can occur times the number of ways the other can occur, so you multiply them. All right, so we can see the fundamental counting principle at work with this first problem. In 2004, the license plates on cars consisted of 3 letters followed by 3 numbers. So that means you could have a license plate like this: A, so 3 numbers followed by 3 letters followed by 3 numbers. So we could have something like 0, 0, 4. All right, you could also have something like X, Y, Z, 2, 4, 6. All right, so your license plates could look something like that or like that. So the numbers could repeat or they couldn't repeat. Either way, you have to know that it's 3 letters and then 3 numbers. All right, so we want to know how many different license plates they could make. All right, so for the first one is a letter, you have 26 different choices. So it's 26 times. The second one's another letter, so that would be 26 different choices times. The third one's a letter, so again, 26 different choices. And then the next one's a number. Now we have the numbers 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So that gives us 10 different choices there. And then the next one's a number, so 10. And then the next one's a number and 10. So all we have to do is multiply all these numbers together, and that is how many different license plates they could actually make. So we got 26 times 26 times 26 times 10 times 10 times 10, and then enter. And there we go. So we got 1, 7, 5, 7, 6, 0, 0, 0. Put our commas in, so we got 17,576,000 different license plates that they could actually make using 3 letters followed by 3 numbers. All right, then we'll take a look at another one. In Maryland in 1912, the license plates on cars consisted of 4 numbers. How many different license plates could they make? All right, so now it's only 4 numbers in 1912, so you could have license plates that could look like this. All right, so that could be a license plate. Or we could have a license plate that would look like this. All right, so either one of those could be license plates. So again, we have a number, and we said we have 10 different choices there. Another number, so 10, and then another number, and then another number. So we have 10 times 10 times 10 times 10. So that is a 1 with 1, 2, 3, 4 zeros. And that gives us 10,000. 10,000 different license plates that they could make. All right. So you have a U-try. It's very similar to those problems. All right. So I want you to go ahead and do that U-try. I can send the answer out later on. All right. All right. So that was the fundamental counting principle. All right. Another way we have to determine how many different ways things can occur is called permutations. All right. This is our permutations formula. Now, this has a little n, a big P, and a little r. Okay. The n and the r, you're going to use those in the formula. So now what it says is it says n factorial. All right, n factorial. That means like if I would have 4 factorial. All right, factorial means it's an exclamation point. 4 factorial means that you have 4 times 3 times 2 times 1. All right, that's what 4 factorial means. All right, so 4 factorial, 4 times 3 times 2 times 1. So this formula says it's n factorial over n minus r factorial. All right, so that's your formula that you can use to do this. Now, the thing about permutations is that order matters. You have to know the difference between permutations and combinations. So with permutations, order matters. That means if you change the order, you're going to get something new, a different arrangement of things. So you have to worry about order. All right? So when order matters, again, we're going to use permutations. So here's our problem. All right? There are 8 people running a race. How many different ways can they finish first, second, and third? All right. So what you do is you take the total number of people that are running. That's 8. And it's permutations because the order matters. First, second, and third. So if you have Joe, Sue, and Carly running in a race, and Joe finishes first, Sue finishes second, and Carly finishes third, well, we could also make it that Sue finishes first, Carly finishes second, and Joe finishes third, and that's a different order, okay? So this, when they're running in a race, it is a permutations problem because if you change the order, you get a different outcome. The first order, we had Joe was in first. The second one, Sue finished in first. So that's what that means, is the order, when order matters. All right, so we got 8 people running a race. We're using permutations because order matters, so it's going to be P. And then they are awarding first, second, and third, so that's 3 different places. All right, so it's 8P3 is how it looks. Now, that means that if we use the formula, it's 8 factorial over 8 minus 3 factorial. So that gives us 8 factorial over 5 factorial. So that gives us 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1 over 5 times 4 times 3 times 2 times 1. Now you should be able to see what happens here. The 5s cancel out, the 4s cancel out, the 3s cancel out, the 2s cancel out, 1s. So it just leaves us with 8 times 7 times 6. And 8 times 7 times 6. $336. All right, so there are 336 different ways to award first, second, and third place. All right, so that's what that means, is there's 336 different ways. If there's 8 people running a race, there's 336 different ways of doing this. All right, now I'm going to show you the shortcut. You have to know how to get this to do the shortcut. The shortcut is using the calculator. Now, a lot of these calculators have the N, have the P and the C and the factorial button on it. First thing I'll show you is where the factorial button is and how it works. All right, so let me just clear this out. All right, so if I wanted to do 5 factorial, I would hit the 5, and then under math, over on probability, there's our exclamation point. So you got to find that exclamation point. It is on most calculators. I checked my iPhone, it wasn't on there. All right, but that's 5 factorial, and if we hit enter, that's what 5 times 4 times 3 times 2 times 1 is. All right, we also have the P button in the calculator. All right, so the P button in the calculator, all right, we have to do it this way. You have to, for this calculator, you have to put in the 8 first, go to math, go over to probability, and then you see there's the NPR button. Now that's what you're looking for in the other calculators. In the calculators I have at school, they're there too, the regular ones. And then we got to put in the 3. So we got 8P3, and we hit enter, and you see 336, which is the same answer that we have, 336. So you can do it in the calculator. So it's setting these up. That's what you got to worry about. All right. So the U tries. I'll let you go ahead and do those. All right. So that I can get the combinations done. All right. So here's our combinations problem. All right. So combinations formula NCR is n factorial over r factorial times n minus r factorial. All right. So the only thing that's different between this, the permutations and the combinations, is with the combinations there's an extra r factorial in the bottom. Okay. Now, important, order does not matter for this. All right, so if you change the order, it's not going to change your problem or change the outcome of it. It doesn't make something new. You don't get a different arrangement when you change the order for this. All right, so our combinations problem looks like this. Mr. Marley's has a student broken up into 10 different groups, and they had to create a poster to represent Pearl Harbor. He will select the best 4 posters to display and award 3 points to all students in the winning groups. All right, and how many ways can he select the best poster? So you should understand this one is a combinations problem, because it doesn't matter if you finish in first, second, third, or fourth. In fact, he's not even going to say who finished first, second, third. He's just finding the best 4, and all the students get the same amount of points. So this one, the order does not matter. It does not matter the order he picks them in. It's not going to create something new. So we have 10 different groups, and it's C because order doesn't matter. All right, and he's going to pick the best 4 posters. So 10C4. So when we use the formula, it looks like this: 10 factorial over r factorial, which is r is 4, so 4 factorial times 10 minus 4 factorial. So in the top, we have 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. In the bottom, we have 4 factorial, 4 times 3 times 2 times 1. And then we have 10 minus 4, which is 6 factorial. All right, and the 6 factorial basically cancels out. In the bottom we have, actually I have 2 times 4. 2 times 4 is 8, so we can cancel out the 8 with the 2 times 4. And we can actually simplify the 9 also. If you don't have to do this, but makes it easier because this becomes a 1 and this becomes a 3. So now in the top, all we have left is 10 times 3 times 7, which gives us 210. All right, so there's 210 different ways to award the points. All right, and again, we can use our calculators. All right, so now I'm going to do the 10C4 in the calculator. So again, I have to put in the 10. I'm going to math. I'm going over probability, and then there's the C button. So I can go to C, and I can hit enter, and I can hit the 4. So now I have 10C4 in there, and there it is, my 210, which is exactly the same answer that we got. All right. So you have 2 U tries to do with the combinations. All right. So you can do those to give you some practice at it. All right. Now, these problems, this is what you're really going to have to be able to do. You're going to have to be able to tell me if it's permutations or if it's combinations. So this is really the important, because you got to know what formula you're going to use in order to do this. Okay? So Jenny's playing with 7 colored tiles. Pink, yellow, orange, blue, purple, green, and red. How many different ways can she place them side by side to form patterns? Now, important thing here is she's forming patterns. So, look, if I use these 3, if I use a pink, a yellow, and then an orange, and I'd keep doing that pattern, pink, yellow, orange, well, that would be different than if I would do yellow, pink, and then orange. That would give me a different pattern because I'm changing the colors. So knowing that if I change the colors I get a different pattern, right away you should see that this one is a permutations problem, because order matters. Alright. Next one, we have Charlie's in charge of making 6 kickball teams in a tournament for their junior class house. How many ways can he form if there are 30 juniors to choose from? All right. So on this one, it doesn't matter the order. If he's just picking them and saying, okay, you're on this team, you're on this team, you're on this team, it doesn't matter what order he picks them in, if he's just picking them. So this one is a combinations problem. All right. Some of these can go different ways, so that's important that you understand that. C, you have to create a song mix of 7 songs for the music for your party. You have 32 different songs to choose from. How many different mixes can you create? Now, this one can go either way. If you have different types of music in your phone, like if you have rock, country, hip-hop, dance music, if you have those in your phone, then by changing the order, it would change the type of the party that you're, the mix that you have. All right, so you want to say if different types, then this is a permutations problem, because order is going to matter. It's going to create a different vibe to your party. If you have all the same type, then it's going to be a combinations problem. So you do have to know the difference between those, and you have to be able to determine if it's permutations or combinations depending on the information that you're given. All right. I'm going to have you guys do the classwork worksheet for homework.